Welcome to Signal and System lecture series. In this lecture, we discuss about time transformation. In addition to point-wise sum, difference, and products, the signal are operated upon with different transformation, basically on independent variable, like time for continuous time signal. So there are three basic transformation of time axis. First one is time shifting, second one is time scaling, and third one is time reversal. So these transformation hold good of for discrete time signals with and as a independent variable. So in this lecture we discussing about the time transformation. The time first one is time shifting. Shifting is also called time translation. Means if we are having the input x and we have to convert into y, signal y, and the relation between the signal output signal is yt equal to xt t minus b. Here b is the real number, it should be real. If b is greater than to 0, means that y is shifted to right by b, and if if b is negative, means below 0, the y is shifted to left by v. So we are taking an example. Here we show that we are having xt, and the xt is the signal between -1 to +1, and it's a ramp function between +1 and -1, and the height is 3. If we are going to apply xt minus 1, xt minus 1 means the value of b is 1. Here if we apply this value to given signal, we find that this output means the signal shift by 1, the signal shift by 1 in right side of x axis. Means if we are having the signal at 0 origin, we are having the signal origin height, that is amplitude 3. So we shifted this signal, origin signal, by 1 right hand side. So the signal value amplitude 3 is at t equal to 1. If we apply the value of b is -1, the signal is shifted left. Signal shifted to left. Here the value of minus at the value of -1, the signal is 3. So this is known as the time shifting and time translation. Next one is time reversal. The time reversal is also known as reflection. If we are having the any x of t, if we reverse the time, means we have to put t equal to minus of t. So we reverse the time. The at the origin the signal is reverse, means 0 to positive side. We have any time signal value, we have to shift into left hand side, and left hand side signal we have to shift in right hand side. So we got the signal is automatically change between positive and negative part across the, and with reflected to with respected to x axis. Next one is time compression and expansion. The time compression and expansion is also called dilation. Here we can see that yt equal to x t x. Here we can see that yt equal to x of at. Here a is strictly positive and real number. If the a value of a is greater than 1, then y is the signal output compressed along the horizon axis by the factor of a. If the signal if the value of a is less than 1, y is expanded along the horizon axis by the factor of 1 by a. So we are taking one example. Here we are having xt in this signal, this type of signal, and we have to time comparison and expansion, and we have xt x2 of t. Here t is multiplied with the factor of 2. So we the output value of yt signal is compressed by 2. So the time limit we have to divided all the time by 2. If we divide this scale t equal to 1 by 2, that means the new result of this point is zero point 0.5. Here we are also doing same thing. -1 divided by 2 that means equal to 0.5, but the amplitude is not changed during the time expansion. So we got the new result here 0 to 0.5, and the left hand side 0 to -0.5. The amplitude remains not change, remains same. In another example, if we having x of t by 2, we got the same. So we have to expand our time scale by 2. Just we multiply our time scale by 2. If we multiply this 1 by 2, means the resultant time scale is 2. So this side we have to expand all the time by 2, and here is same in left hand side we have to expand all the time by 2. See, this is known as time compression and expansion. Here, two perspective on independent variable transformation. A transformation of the independent variable can be viewed in terms of the effect of transformation has on signal, or the effect of transformation has on horizontal axis. This distinction is important because such a transformation has positive effect on the signal and horizon axis. For example, time shifting transformation that replace t by t minus b in xt can be viewed as a transformation that shifted the time signal x right by b unit, or shift the horizontal scale left by b unit. In our treatment of the independent variable transform, we are only interested in effect that transformation has on signal. If one is not careful to consider that we are interested in signal perspective as opposite to the axis perspective, many aspect of independent variable transform will not be sense. So these are the main perspective about the transformation. In this lecture we study about the time scaling, time shifting and time transformation. Thank you.